You've just taken your quiz on solving systems by graphing and substitution. There is one more method. All right, so there's going to be a lot of writing on this. Sorry, not sorry. All right, so today's objective is I can solve systems using the elimination method. So the objective is that you can solve systems of equations using the elimination method. As you go through, there's a lot of writing, so if you want to pause once it's all up there, and then you can press play when you're ready to continue listening to me. All right, so first thing we need to look at is reviewing what cancels. What cancels is opposites. Opposites. All right, so let's look at some examples of opposites. So if we had 2, the opposite would be, let's get some colors. -2, because 2 plus -2 would give you 0. It would cancel out. All right. 5x and -5x. That would cancel out. Take a second and try the next 2. All right. -6c plus 6c would cancel out. And -15f and 15f would cancel out. So if you add opposites, you'll get 0 pairs. If you have as many negatives as you have positives, it will cancel out. Whether there's a variable there or if it's just an integer, they will cancel out. We're going to use this concept, fancy, to use the elimination method. All right, so make sure you got that all copied down. And let's move on to the steps of using this method and see how this applies. All right, step 1. All right, step 1 doesn't actually have what I need in there. So we're going to add a little extra text box over here. And we're going to put equations in standard form. That's the ax plus by equals c. So we're going to be using standard form again. It's going to make life really easy. Just trust me. This method, when it's in standard form, just makes one-step equations after we get it set up. So it's something we definitely want to take advantage of. And this is what makes it easy, is having it in standard form. So put the equations in standard form, ax plus by equals c. All right, and then once we do that, I'm going to write all the steps, and then we'll go in and actually apply it. So step 1 is going to be to multiply the equations until either variables' coefficients are opposites. So it doesn't matter if we want to make opposites with the x terms or if we want to make opposites with the y terms. Just like when we isolated variables for substitution, we isolated the easiest one. It didn't matter if it was x, it didn't matter if it was y. We went for the easiest route. So same thing when we do elimination. Let's go ahead and do this step. All right, so we have 4x and 2x, and we have -2 and +3. So 4 is a multiple of 2, so that's going to be the easiest route. That doesn't mean that we couldn't also make y's opposites, but I think that this is the best route. So since 4 is a multiple of 2, I can multiply the second equation, the whole thing, by -2. I'm going to put it in parentheses so it doesn't look so weird. All right, I'm going to multiply the whole thing by -2, and what that's going to do is make opposites, because what's 2x times -2? -4x. So then we'll have 4x and -4x. That will be opposites, which later we will cancel. If I wanted to cancel the y's, I'd have to multiply the first one by 3 and the second one by 2 to get -6 and +6y. So this one that we're choosing to do is the quicker route. So technically, we'd be multiplying this one by 1. You don't actually have to write that, but if you want to see that, essentially you could end up multiplying both equations to make those opposites. Technically, we're multiplying by 1 because we're not making any changes. And they were already in standard form for us, ax by c, ax by equals c. So we didn't need to do that step here. This is the first time we're doing it. We'll keep it simple. You need to pause, otherwise I'm going to keep going. All right. So I'm going to actually apply this. So that means that now if we multiply the first equation by 1, still 4x minus 2y equals negative 8. Maybe a perfectionist. I'm going to make this a little bit bigger. Eee. Ah! That's good. No, it's too big. It's too big. We'll do 18. Okay. All right. And then the second equation, remember that if we make changes to an equation, we have to do it to each term. So that way we keep the relationship between each term the same. We're not actually changing the relationship of the values in the equation. So this would become negative 4x. And 3y times negative 2 would make that negative 6y. And 20 times negative 2 would make that negative 40. All right, I'm going to line them up a little bit better. There we go. So step 2 is that we are going to add the two equations vertically and then solve for the remaining variable. So this is called the elimination method because when we add these, negative 4x plus 4x, that's going to cancel out. It gone. So now we're just going to add what's left over. So we have negative 2 plus negative 6y. That's going to give us negative 8y equals negative 48 from the negative 8 plus negative 40. This is just a one-step equation. I'm assuming that is what they wanted us to put here. So let's put that there. I can't quite remember exactly how it wanted it. Yeah, that was a lie. This goes here. Okay. So we still need to solve for that remaining variable. So we eliminated x, and now we have one variable that we can solve for. So we're going to divide both sides by negative 8. And that's going to give us y equals 6. So we just solve for one of the variables. Okay, step 3. Step 3 is the same as if we were using substitution. We don't need to eliminate twice. We eliminated the first time to find one of the missing variables. Now we can just plug in or substitute the value from step 2 into either original equation, solve for the remaining variable. All right. So now that we have the y value, all we have to do is plug it back into one of the original equations before we manipulated anything and solve for the corresponding x value, so the one that we haven't solved for. Give you a minute to copy that down. If you want extra time, just go ahead and pause. All right, so let's plug it back into, this one's got more positives. Let's do that one. All right, so the equation was 2x plus 3y equals 20. So we know the y value, so I'm going to replace y with 6, and we're going to solve for x. So that gives us 2x plus 18 equals 20. We'll subtract 18 from both sides, leaving us with 2x equals 2. And solve for x by dividing, and you get x equals 1. All right, in our last step, isn't really a step at all. More security, check your solution. Just like if you were doing substitution, when you get to a no solution or infinite solution, when you would be using the elimination method, both of them would cancel out, or both would eliminate, and you'd be left with a true or false statement, and you could determine no solution or infinite solution. But we'll do more of that later. Just thought it would be useful to mention. So